Hey everybody. So in this article we're going to be looking at an analog to digital input mini module and a digital to analog output module. So over here on the left we have an ADC mini module that has 4 inputs, and then over on the right we have a DAC which has 4 outputs. This ADC input board could be used for reading 0 to 5 volt DC signals or variable resistance or digital contact closure signals. The DAC on the other end is going to provide a close to a 0 to 5 volt DC output. The maximum output of this module is based on the supply voltage to the chip. And basically how we're powering the chip right now is we have a USB cable coming into our particle photon module, and then that 5 volt supply comes out of the photon module through its VN pin, and then that 5 volt supply comes through the I2C cable to the mini module. And what happens is whenever you come in through that USB connection on the photon and then you tap off that VIN pin, you're actually going to get a little bit of voltage drop. It's somewhere around about 4.6. So the maximum voltage output we're ever going to get out of this DAC is about 4.6 or so due to that. If you were actually supplying this mini module with a real 5 volt DC signal, you would of course have a 5 volt DC output. On the ADC board over here, I have a potentiometer connected, and I have the A leg of the potentiometer soldered to the 5 volt supply line that comes in on the I2C connection. The B leg of the potentiometer has been tied to the ground terminal of the board, which is the center terminal, and the wiper leg of the potentiometer is connected to ADC1, the first input. So basically the idea of this application is, what if you have an analog signal at location A and you need to mimic that analog signal at location B? So maybe you've got a sensor installed in a barn or another location, and you have something that needs to read that sensor at another location. Well, this is a way to take that signal from location A and then mimic it at location B. So as our analog input changes on this board, the analog output of this board will change. And we're doing this all through Particles Cloud by publishing an event from this ADC board. Whenever the status of this input changes, we're publishing a new event that shows what percentage of the input we're at. So if we turn the potentiometer all the way down, we have a percentage of 0. If we turn it all the way up, we have a percentage of 100. Then that event is published to the Particle Cloud. This device is subscribed to that event. So whenever it sees that new event, it's going to set the output of this DAC based on that percentage. So if it reads 0% on the event, it's going to set it to 0 volts. If it reads 100% on the event, it's going to set it to the maximum output, or somewhere close to 5 volts. So we'll just take a look here and see it in action. Right now the potentiometer is turned all the way down. If I turn it all the way up, we'll get an event that says 99.63 for the percent, and we'll see on our voltmeter here we now have an output of 4.6 volts. I'm just connected to the DAC output of this board with this meter. So if we turn it down about halfway, there's about 50%. We're going to see a voltage of 2.38, which is about half of the output. And of course, if we turn it anywhere in between, we can change that percentage value and change the output of our DAC. So this is kind of like a worldwide ADC to DAC. You've got an analog reading on one location, and you're mimicking that analog reading as an output at another location. So that's about all there is to it. All of the source code for the application that is in this board as well as in this board is on this project. So you can feel free to take it, look at that sample code. We'll also have links to the products used here. And this is a 4-channel setup. We have 4 inputs here and 4 outputs here. But in this application, I only did one channel, but of course you could do all 4. So that's about it for this application. If you guys have any questions, be sure and let us know. Thanks, and have fun.